Good morning, good afternoon, good evening, depending on where you're at in the world. We're quite happy to have another edition of our webinar series. Our presenter again will be William Nassauer. This is his second webinar. As a reminder, Bill is a 10-year veteran of the mining industry, MBA from Columbia, experienced in general industry, having spent time in strategic planning for General Motors. Bill comes to us with experience from all over the mining world, having done project management in South and North America, account management, working with many of our mining customers throughout the world, and has spent the last few years as product manager of our ProVision machine guidance system. Quick reminder of the legal notice. This is copyrighted material, Modular Mining. Quickly, a little bit of the ground rules beforehand. Should you have questions during the webinar, you'll see a chat feature in the lower left-hand corner of the screen. Please feel free, as the questions occur to you, to ask the questions in that chat. We'll save up some of the more interesting questions for the end, where I'll read them aloud and Bill will respond to them. And others will respond to directly in the chat. And finally, some of those that are a little bit more difficult to answer in this format will give you a call or send you an email after the webinar to respond. So not everybody who attends these webinars is entirely up to speed on modular mining. For those of us who don't know, Modular has been around since 1979. We have offices throughout the world as a leading provider of mine management systems. Essentially anywhere there's mining, we have a presence. Our IntelliMine solution is used at 18 of the 20 largest mines in the world. We've done over 235 installations. We're used by many of the major mining houses you see throughout the world. And some of you might see your company's logo up there, and we appreciate your business. Today we'll be presenting on the topic of ProVision. And ProVision is effectively one of the 4 pillars of our IntelliMine software suite. Those other products include our dispatch fleet management system, which many of you might be aware of, which manages the assignments and trucks and many other things. ProVision, which is machine guidance, which Bill will go into in-depth detail on. MineCare, our real-time diagnostic maintenance system. And MineAlert, our new pillar that we launched at MineExpo on safety products. All of our IntelliMine system rests on top of network infrastructure, our branded MasterLink network or third-party networks, as depending on what's at the mine. Support services to ensure that everything works and is up and running, installed, and just makes the process very smooth. And our consulting services, which provide the change management, best practice, training, and really that consultative approach that allows the large-scale mine management systems to be utilized to their fullest. Finally, before we begin, just a quick question. Curious to us, but might be curious to you as well. But what future ProVision applications do you think would provide the most benefit to your mine? We'll quickly give you a chance to respond in, and then we'll see what people think. While we're doing that, again, reminder of the rules. We'll have a chat in the lower left-hand corner. And we'll go ahead and skip to the results here real quick. Looks like graders. And graders seem like a very obvious choice to be a application for future ProVision. At this point, I'll go ahead and turn it over to Bill. Bill, tell us a little bit about ProVision.
Okay, thank you, Andrew. It's my pleasure to be able to do basically my second webinar focused on machine guidance systems. Let's go ahead and jump right into discussion about ProVision. So what I wanted to do quickly was just define for everybody what we consider to be machine guidance systems in the context of the mining industry, and So for us, that is basically fleet solutions that utilize a high-precision global navigation satellite system, or GNSS, that are designed to improve productivity of equipment by providing operators continuous guidance and navigation information. You'll notice it doesn't say high-precision GPS, it says GNSS, which is now a more common acronym for this type of technology, because it's utilizing not just the GPS, United States GPS satellite systems, but those of other nations as well. For Modular, as you saw in the slide overviewing IntelliMine, high precision, our ProVision line of products is one of the 4 pillars that make up our business. So this is obviously a big thing for us. We've got well over 1,700 deployments of ProVision systems in the field. Those are ranging in type, primarily excavators, dozers, and drills, and we have a presence in pretty much every mining industry in every corner of the world. So this is a little bit of a snapshot of this, so you can see what it looks like in terms of industry. We've got ProVision systems in the coal industry, copper, iron ore, gold, and the others as well. And it's actually spread quite evenly across those industries. And in the same sense, by region, we're spread very widely across the world. We've got a fairly even presence in the Americas, Australia, and we're growing little by little in Asia right now. But there's pretty much no corner of the world that we're not present with high-precision machine guidance. So let me show you a little bit how this system has evolved over time. It was born back in the mid and late 90s. Our system was the first to use augmented GPS, which in reality is not just GPS, but it added the Russian GLONASS system into the capability. It was at that time running on a UHF network, and in 1999 we expanded the product line, and it actually became the ProVision product line when we added the drill system. This was the first time that anybody had provided the ability to create onboard designs for hole patterns and for surfaces, allowing the operator to create ad hoc areas of work. In 2001, we expanded the product line again by adding Dozer systems. And in 2003, that was our first major redesign of the system. This is our 2nd generation system, or ProVision 2. It was redesigned, the user interface was redesigned to be more user-friendly. We ported it to our new MasterLink architecture and started to use 802.11 Wi-Fi networks for our communications backbone. In 2007, we added the ability to interface with what was then Novariant, and actually now is Trimble's XPS system for mines that have poor GPS satellite coverage in areas where the pit is particularly deep, or depending where you're located around the world, just the way the constellations happen to line up. In 2009, we added the backhoe system, which is basically just a shovel system with a backhoe configured bucket. And in 2011, we released our 3rd generation system, ProVision 3, and this is what I'm going to focus on the rest of the presentation. This system has a number of brand new features, such as the shared digital terrain model, which I'll talk a little bit more in detail about. We're using standard Microsoft technology and a whole slew of other improvements to the system that have made it a much better overall product. So how does the ProVision system work? You'll see here there's kind of three different pieces of the puzzle, one of which is extremely important, and it's external to ProVision itself, and that's mine planning. All of the information that the system needs to help the operator guide them in their work comes from mine planning, and also to some extent from dispatch as well, if you have a connection to a dispatch system. But mine planning provides all of the surface designs, all of the geological data, dig limits and hazard information, which is input into the system through this Office application, which is a Windows client, and it is basically installed on any computer on the mine network that needs access to the system. And the Office application then provides to the mobiles out in the field this information on an as-needed basis. So if the machine happens to be in an area where there is a design surface, or if that design surface is assigned to a piece of equipment, that information is provided in real time to the machines out in the field. And back the other direction, as the machines continue to work in the field, all of the elevation data and other production information that is gathered as it's working is uploaded back, synchronized in real time to the central system. And then this is provided back to mine planning in the form of exports that can be used to calculate volumes moved and update the terrain model in the planning system. And also there are reports that are available through the Microsoft SQL reporting services system that's incorporated in the Office application.
Hey Bill, hate to jump in here, but we had a great question come in. What mine planning systems can be imported into the ProVision system?
Well, basically, we can import from any planning system. The standard, basically, you export that information into a file format that we can read. And in reality, we have a tremendous amount of flexibility there. We can take many different formats and just create conversions on an as-needed basis. We're also working with MineSite, a Mintex MineSite product at the moment, to have a direct integration, which is coming next quarter. And over time, we plan to expand that to include the other major packages as well, such as Vulkan and Mindscape and others.
Thank you.
So anyway, the point here is that the mine plan basically turns into the work plan and vice versa. So let's talk a little bit about the shared terrain model. This is an important change in ProVision 3 from our older generation systems. Basically, this means the terrain model is shared between any ProVision systems out in the field who are working in the same area. So this is particularly important when you have dozers that are working in teams, or if you have dozers and loaders working together. They each see each other's progress on the projects that they're working on. This also means that if you were to power cycle the hardware in the field, no information is lost. So when the computer comes back up, you get all of the terrain data, all of the progress lines, everything that's been gathered up until the moment is brought back on screen, and you don't have to start again from zero. The information is all centrally managed, and that means that we're able to support keeping track of all the latest terrain information and populating out to all machines out in the field. Okay, so that's a general overview. I wanted to go into a little bit of detail on each of the three major equipment classes that we're going to be supporting in ProVision 3 now and in the near future. So we'll start with the Dozer system. The Dozer system is designed with the main goal of providing elevation accuracy to improve bench and ramp consistency for dozers. The system also has a number of tools to report on volumetric KPIs and other operator feedbacks are incorporated, again with the intent of improving the productivity of operations when Dozer operators are trying to build surfaces. And we have incorporated into this system a very easy to use tool. It's actually a group of wizards that allow the operator to create on the screen simple projects, and all updates are automated between the central system and in the field. So let me show you a little bit about what a couple of these things look like. This is a screenshot of the Dozer system itself on the mobile. You can see here, there's a little image of our PTX to the right. It's a 10-inch screen, and this screenshot happens to be the side view. You can see the terrain model represented here with a line that indicates the desired surface shape. And some basic information on pitch and roll and elevation. Aside from the side view, there's also a plan view. And this shows the operator, basically, you can see here, this happens to be a sample of a machine that's working on a ramp. And the information that's not black, the areas that are not black that are colored in, are based on elevation data that's been gathered in that location relative to that which is desired in the planned surface. So the white area happens to be pretty much on grade, and the blue area is area that needs to be cut in order to meet the design. So this is basically showing a cut and fill model of the area, and it's updated as the machine moves all the time. And I mentioned that there are some onboard wizards in order to create surfaces. This is just one screenshot of part of one of the wizards, in this case to create a flat surface. But there are wizards to create ramps and to create fixed inclinations. And this provides the Dozer operator with a lot of flexibility to, and takes perhaps a bit of the load off of the mine engineers to constantly have to have designs input into the system for simple things that would be easily managed by the operator himself. So that was the Dozer. Let's talk a little bit about the drill system. The ProVision drill system, the main goal of it is basically to guide the operator to drill holes positioned according to the pattern that's been input into the system, and also gather depth information in order to, with the end goal of trying to improve blast efficiency and machine utilization and so forth. The navigation system also has the advantage of being able to, find holes in times of poor visibility at night with poor illumination. You would also be able to eliminate the need to survey individual hole positions and mark them with stakes or spray paint holes on the ground. The idea here is that you can eliminate this and use those resources in much more valuable ways. And we have an optional module called the drill hole stratification module. This basically takes sensor data on from a number of different parameters such as pull down pressure, RPM, and penetration rate, and so forth, to calculate basically the energy required to drill at different depths as the machine is drilling a particular hole. With this profile, we're able to apply it to site-specific geological information and identify the specific rock and the material that's being drilled. And blast engineers are able to use this information in order to improve performance in blasting and save explosives. And I've got a case study to illustrate this. In this case, we had a couple mines in Brazil who had the objective of a couple of objectives, actually. One is improve efficiency at the crusher by reducing rock fragmentation, reducing drill and blast operational cost, and improving loading efficiency. So you'll see what they did is they used a ProVision drill system with the whole stratification module, and you can kind of see the before and after here represented. What you're looking at is basically use of explosives, and by utilizing the system, they were able to create a pretty dramatic improvement, greater than 20%, which represents a significant amount of savings on a year-by-year basis at the mine site. So that's drills. I don't have screenshots of the drills because we're currently in the process of developing our third-generation drill system. So I hope to have a lot of detail on that available soon. So let's start talking about our loading units, which, and by loading units, I'm referring to wheel loaders, front shovels, and excavators, backhoe configured shovels. So the loading system for ProVision 3 has a number of new and good features. One of them is real-time 3D bucket positioning. We're able to use inclinometers on hydraulic shovels for front shovels, and also for backhoes to identify the exact position of the bucket. So when you combine that with the heading and position of the machine, it allows for more accurate digging and the ability to create layered materials in the bench, and to guide the operator to dig under those conditions. Integration with mine planning software. This allows us to update the field system in near real time to changes in ore boundaries, and we're able to also alert operators to when they when they cross the line, for example, when they deviate from the plan, when the bucket crosses into the next block of material, and they have not changed the material correspondingly. We're able to identify that and make sure that they know what's going on. So a few screenshots on the loading system. Here's one from the shovel. This is showing the top view, and actually, our mobile system is configurable in a number of different ways. This view can be changed, so this happens to be the view where you have a landscape format of the navigation screen. You're able to see here the progress line, the area that's been dug out. You can see some material polygons. We have a elevation indicator on the left side of the screen, and some basic information to let the operator know what material is selected and what's being detected by GPS. This screenshot shows a front view. So in systems for front shovels that have the bucket positioning system installed, we're able to display the material type, or rather the layered material blocks in a front view, and indicate to the operator with that target exactly where the bucket is positioned relative to these material types. So in mines that do this type of digging, this can be a very useful tool to improve accuracy in basically material identification and management at the shovel. And for our wheel loaders, we support tramming loads. So basically, the high precision system is able to do a better job keeping track of exactly where material is being pulled from and dumped to, using better detection of location versus our low precision system. I've also got a case study for the shovel system. So this is a case of one of our customers in South America, a very large coal mine, who was able to demonstrate a very significant improvement before and after implementing a ProVision system. What's being illustrated here is basically changes in bench elevation, variations between the planned design and the actual bench, the way it was dug by the operator. So you can see they were leaving an average of 3.2 meters on the bench before the ProVision system was installed, but this accuracy was improved to under 40 centimeters with the ProVision system installed. So the improvement here is extremely dramatic, 87.5%, and it was able to be done in a very short time frame, in just over 3 months. So this had a very profound effect on the ability of the mine to improve their, to manage drainage and also to avoid rework, which is a significant cost adder in mining. Okay, so that's basically my overview. I know it's kind of a short and sweet overview, and I'd like to be able to entertain questions and wherever we've got them.
Thanks, Bill. A couple questions did come in, and we'll start with one out of the oil sands. You mentioned the market share by different mining industries, but tell us a little bit more about oil sands and what some of our customers are utilizing high precision and ProVision for in the oil sands industry.
Let's see. So we do have a lot of systems installed in oil sands. The systems are being used there, just like everywhere, for elevation control and for, to a lesser extent, identification of the different grades of material. Oil sands is kind of like coal in the sense that it's for the operators, a lot of times it's obvious what's the good stuff and what's not. But there's many different ways that the system is used. It's also used for dozers to manage not bench, but the slopes of the tailings and the dumps, and it's something that's extremely valuable to them.
Thanks. Another question came in about the shared mine plan. How many pieces of equipment, is there a limit or a capacity on how many can share one terrain model at a time?
No, not really. We're only limited by the capacity of the servers to handle the amount of transactions that we have going on, and that's something that we're able to control, knowing going in what kind of fleet size we're dealing with, so that we make sure that the servers the servers and the network itself is designed from the beginning, to support that type of load. But really, there's no limit as to how many machines that the system can handle, or the amount of sharing that can happen.
A question came in about the level of customization on the screen itself. Are the colors, or how much is customizable to the unique desires of the operators in the mine?
Yeah, the colors are all highly customizable. You can define everything from the material, the different colors that correspond to different material types, how you want to represent elevation, if you want high to be red and low to be blue, or vice versa. All of that's configurable. The screen the layout can be changed, and on the main menu, which I didn't really show, you can add and remove buttons for different functionalities that you want. So there's actually a number of options that can be turned on and off, depending on what you want to focus on, and how you want the operators to access the information.
Great. Let's see if I can grab one last question here. When it comes to the onboard design plans, the ones that are made in the cab, are those shared back in the digital terrain model, or how are those handled?
The onboard designs?
Yeah.
They are. So the so-called digital terrain model is basically it's a model of it's a snapshot of the mine. It's also we store a historical record of exactly what happened. But what it is it's elevation data basically. It's the actual data that's been measured out in the field. In addition to that, we store the plan design, which is the actual design surfaces that are imported into the system. So you're able to see both, the as-built as it's being pulled from the field and the design information that's there and compare them at any given time in the past, up to a limit because we can't keep everything. It's a ton of information and, at the moment.
Great. So that's reached basically the, we had one other question about ProVision and dispatch on the same display. And I know that comes up a lot. So Bill, could you?
Yeah, just to clarify on that. So dispatch and ProVision are highly integrated, which means that you're able to run all on one screen. So basically, the same screen will dispatch trucks and allow the operator to look at all of the the guidance functions. So yes, the answer to that question is yes.
I know that's a big point of interest in the industry right now, is reducing the clutter and the amount of screens in the cab, both from just an ergonomic standpoint, but also a safety standpoint, having fewer things in the line of sight.
Right.
So that appears to be most of the questions that have come in. As with all of these, we'll email you a link to a recording of this webinar, and look forward to seeing you in the upcoming webinars. I do encourage you to send us an email, as you can see, products@mmsi.com, should you have any ideas for future webinars or topics you'd like to see us discuss. Thank you all for coming. Bill, thank you for presenting.
Okay, thank you.
And hope you all have a great morning, afternoon, evening, wherever you're at in the world. Have a great day.